Hello friends, you're welcome to tmath tutorial. In our today's class, we are going to be treating question on coordinate geometry. So look at this question. We are given this question, find the equation of the straight line perpendicular to 2y equals negative 3x plus 5 at point 3, 1. Right solution. This is the first equation we have, that is 2y equals negative 3x plus 5. Don't forget, equation of a straight line, because we are dealing with straight line here. Equation of a straight line is always in this form: y equals ms plus c, where our m is the gradient. So when you are given this kind of equation, you must write it in this form. So there is what do I call it, coefficient at the front of this y. So we have to eliminate the coefficient by dividing all through by 2. You divide by 2, you divide by 2. So this cancels this. Therefore, our y now will be equal to what? Negative 3 over 2x, then plus 5 over 2. This is the form of equation of a straight line. So this is line 1, the first line. So now, can we get the gradient of this line? The gradient of this line is m, like I said, the m. So we can say that our m, let's call it m1, equals negative 3 over 2. So this is the gradient of the first line we are given. So they now ask you to find the equation of another line that will be perpendicular to this one, that would to this line. So this is it. For two lines to be perpendicular, it means that the gradient of the first line is negative inverse of the other one. You get what I'm saying? The gradient of the first line is equal to the negative inverse of the other line we want to get now. So that means this is my m1, that is the first gradient. So the second gradient now, I will go and say m2, that is the gradient of the line that I have not known, m2, equal to minus open brackets negative 2 over 3. You can see that I turn this one, that is the inverse of negative 3 over 2 is negative 2 over 3. Very fast. So m2 equals negative open bracket negative 2 over 3, because of what I said. I said for two lines to be perpendicular, the gradient of the first line is equal to negative inverse of the first line you are given. Negative inverse. The gradient of the negative inverse of the first line you are given, which is what I've written here. Negative of the inverse of this. So which is this? So can we find our m2 now? You can see m2 equals 2 over 3, because when negative multiplies negative, you get positive. So we are having 2 over 3 here. So now, look at it now. Therefore, we can say that because we are looking for the other line that is perpendicular to this line, this is the other, that's what we are looking for. So we can say that our m equals, m2 equals y minus y1 over x minus x1. So what's our m2? 2 over 3 equals y minus, so you come to this point that you are given. This s represents s1, y this 1, I mean this 3 represents s1, y1 represents y1. So we are having gradient 2 over 3 equals y minus, what's our y1? 3. y1 is 1 over s minus x1, that's 3. So we can cross multiply. So when we cross multiply, we are having 3 open bracket y minus 1 close bracket equals 2 open bracket s minus 3 close it. So when we open the bracket, we have 3y minus 3 equals 2s minus 6. So we collect like terms, so that we have 3y equals 2s minus 6 plus 3. So 2y equals 2x minus 3. So can we divide both sides by 2? Divide both sides by 2, by 2, by 2. This will cancel this. This cancel this. Therefore, my y equals s minus 1 and a half. So this is what they asked us to find. This is the equation of the second line, and that is perpendicular to this equation. So this is the fastest way to do it. So when you are doing it in JAM, this is what you just do. Just quickly find, write the equation you are given, write it in this format. You write it in this format. That is y equals to ms plus c. Then locate your m. So when you get your m, the gradient of the second line will be the negative inverse of the gradient of the first line you are given. So, and you find the equation this way. That's it. Thank you for watching. Do well to like and subscribe to my channel. Thank you.